Right. So the purpose of this chat for Eric and AJ, who are joining us, is the language model evaluation harness is a framework that we built a while ago for evaluating large language models. It is really useful and in many senses pretty excellent, but definitely has some kind of struggles, and the design is not ideal. I think is a kind way of putting it. Kind of the core problem is that the original intention of the harness doesn't really line up with its current use. So the original intention was primarily focused on wanting to be able to run the exact same evaluations on the GTB2 API, sorry, the GTB3 API, as on our systems, as on our models. And as a result, because the thing that was offline, the thing that was not ours that we were hoping to run was this hosted online service, we built it around trying to remember exactly where the code is so I can show it to you. But we built it around this idea that you're sending requests, you're batching data, and you're sending requests to a server, which then processes them and handles them and feeds stuff back to you. And as time has gone on, there's been a lot more open source released models, and I guess it's probably in tasks. And we now find that we're mostly evaluating other models that we have locally.
It would be it's
Okay, it is just an Eval base. We now find that we are mostly evaluating stuff that we have locally. So, yeah. So we have this abstract class, whatever. The new GitHub UI is interesting. Yeah, so we kind of have these things structured as a request where you have to generate a request and then send it to the model to run. And this has kind of caused some weird design quirks and kind of the way it's laid out. And this also is just, the general design is pretty limiting. The person who used to head this project had a extremely strong aversion to ever making breaking changes for anything, even when the original thing was really, really bad. So the most egregious example of this is that we support arbitrary Hugging Face models. We don't tell the user that we support arbitrary Hugging Face models, though, because what we tell the user is that we support GTB2. And it turns out that if you provide an argument for a model that isn't GTB2 to the thing called GTB2, it will call an arbitrary Hugging Face model. I don't give a fuck what Leo says anymore. Like, this has to change. This is awful. This causes so many confusions and so much misunderstanding. We cannot continue to do this. And I think that as a whole, we really want to kind of have a more deliberate design and kind of figure out how we can do better when it comes to making, like, the code base has kind of really grown over time, and new functionality has been added, and new things that people wanted have been added. So now there's a fork of this library, for example, by the Big Science Research Project, which several of our members participated in designing and creating, but which allows you to do prompted evaluation. So if I open that quickly, there is an example here somewhere, right? No, I guess there isn't. I thought the README had an example. But the idea of this version is that when you have if you want to experiment with the impacts of particular prompt framing, for example, so you have like a base data set. So for example, you might have as your base data set Lambda. Let me just stop sharing my screen. So if you have as like your base data set Lambda, you want to preface it with some kind of prompt to influence how the model behaves and kind of study how that prompt affects behavior. And so that's what that fork allows you to do. I want to, in general, kind of upstream that as well as integrate some of the improvements it has. So it has integration with the Accelerate library. It supports encoder decoder models, which our version may or may not do right now. I don't remember if that ever got upstreamed. So that's really something we've talked about upstreaming multiple times. But kind of in general, what we want to do is have have a more general workflow, um, and more applicable to the kinds of problems that we want to solve nowadays, and then kind of redesign the library around that. And I think many of the core original ideas are very good. So, for example, the library never touches tokenization. It assumes that the model knows how to tokenize data. It assumes the model knows how to run itself. Basically, what the library has you do is, if you have a task, you define an API interface, which creates, which loads your data and creates tasks, and submits those to the model. And if you are introducing a new model, what it does is it defines an API interface for calling your model, and then handles all the in-betweens, and it tells you how to orchestrate it and how to evaluate it, and what scoring to use and all that jazz. And I think that approach is really good because it's made it very flexible and modular. But some of the lines are not probably drawn in the right spot. So Haley and I have been working in kind of a workflow list. Do you want to pull that up? Did you put that on Notion? I know you talked about putting that in Notion.
I have not put it on the Notion yet, but it is. I can link to the message or something. It's.
Oh, yes, there it is. So it's in the who's emoji. It's in the uh, harness refactor branch of the or thread within the LM Thunderdome channel. Parallelization is something I didn't call out specifically, but yeah, no, our models are now big. We need to be able to parallelize them. So, at a high level, the workflow here is basically like pick a model, pick a data set, grab the data from the data set, apply kind of transformations, prompts, chain of thought reasoning, I think, is something we've talked about having be covered by this. Few shot examples, end up with whatever you need to send it off to the model, and get back the response, and then maybe apply some kind of sampler, some kind of solution selection technique, something we've been talking about very recently. With a couple sub bullets there that are pretty important, being like, parallelizing the model automatically, loading the model onto GPU. PyTorch now has features that let you not load it not initialize it in CPU. We also want to so the way that the Hugging Face library works, because the Hugging Face library is extremely poorly optimized, is that if you load a model that is in low precision, it initializes it in high precision first, and then loads it in low precision. And what this ends up meaning is that if your model only fits on GPU using, for example, int8 precision, you can't actually load it in the Hugging Face library, because it will, out of memory during initialization, when it tries to load the model in higher precision than that. I'm not sure if they've updated it, so it will at least now do it in FP16, but it at least used to be the case that it would literally try to load the model in FP32.
My understanding is that that's correct.
I could not understand that. That was really garbled, Eric.
Sorry. My understanding that maybe still a problem.
Did someone else understand that and can repeat that?
My understanding is that it's still a problem.
Oh, that's still a problem? Okay, yeah. So it's very possible that the model will actually try to load in FP32. And obviously FP32 is twice as much information to load the same data as FP16, and 4 times as FP8. As int8. I mean, also FP8, because H100s are coming out soon. We actually already have access to H100s because we're cool. But H100s are coming out soon. They support FP8, and that's going to be really big for doing local runs and local evaluation. But if most people are doing stuff through the Hugging Face library, then at the end of the day, we need to be able to kind of get around that. We actually do have a patch that fixes this, but the last time we tried to submit it, there was resistance to merging it for reasons I don't understand because I have very strong design conflicts with the people who maintain the Hugging Face library. But that's kind of beside the point. So these are kind of our high level goals. There's a couple other auxiliary features that are really nice to have. So for example, we have the beginnings of a deduplication analysis. So in the like GTV3 paper, they showed this really interesting plot. Language models are few-shot learners. Oh, I'm not sharing my screen anymore, am I? Let me share my screen again, so you can see what I'm excited about. So in the original GTV3 paper, contamination. No, that is not it. Where is this plot? How many times did they use this word? They used the word contamination 950 times. Wow. Alright, well, give me a moment. I'll find it in a moment. Here we go. So what they did was they looked at a 13-gram overlap. So they said, we're going to assume that a sequence in the training data and a sequence in the test data are the same, or we're going to count them as the same if there's an overlap of 13 characters or more of identical repetition. And what they did was they ran the evaluations first using the entire data set and then skipping over all of the data points where there was a 13-gram overlap. So this is on a data point by data point basis. So they're subsetting each of the evaluation tasks to the stuff where there isn't contamination. And they show this plot here on the x-axis. You see percentage of data of data clean in Dataset. So these tasks over here are basically completely unrepresented in the training set. QUAC, QUAC, is like basically 100% contained in the training dataset. And this is the change in performance. So you take the evaluation on clean data and then you subtract the evaluation on all data. So a higher number means that performance went up. Performance went up a lot. A lower score means that contamination substantially impacted the performance. So for example, for drop, we see that like there's a 20% increase in score if you count the contaminated sequences. Now, I don't super agree that this is the right way to measure it, but this kind of thing is really interesting and really valuable. So we kind of implemented something like this, but it's not super well documented and it's kind of hard to use. And that's probably something that we're going to want to integrate as part of the scoring functionality.
I was wondering about the decontamination analysis. So like basically, as it is right now, yeah, it's like sort of unwieldy to sort of have that in the main loop and like need to run a train set scan. I think maybe anytime that you about this.
So what we have, so that if you train a model on new data that nobody's analyzed before, you need to do a very expensive pre-processing of running 13 grams and computing all these things so that you can actually do the decontamination. We did this pre-processing for the pile and released that somewhere. Genuinely don't know where one would go to download it, but I've been told it is on the internet somewhere because I know somebody outside of Luther who has used it before. But
okay.
Yeah, so the library provides functionality for building the 13 grams dataset, which is intended to be done as an offline process once. And then the online process is checking the data as you load it against those 13 grams to decide whether or not to count it.
That makes sense. Okay. What I was wondering is, would the decontamination analysis make sense to sort of have as a separate repo or tool, and then basically the feature is the data set after whatever, like, take the data points after whatever transformation is applied, and then like output a Hugging Face data set that only has the uncontaminated data points.
I
So
don't
that sort of doesn't still get it.
I don't think so. And there's a
Okay.
couple reasons for that. One is that that feels kind of clunky and kind of feels like it's fake standalone in the sense that like it is nominally standalone, but you still kind of have to use our library to do the analysis. It's also actually more work. So one of the clever things is that if you're most of the time people who are interested in decontamination analysis don't just want the decontaminated analysis. They actually want to compare analysis on decontaminated and contaminated data. So by running those two things jointly, you only have to do you only have to like do one pass over the data set. So what you do is you load every single sequence, you run every single sequence to the model, and then if it's contaminated, you only add that to one bucket, and if it's not contaminated, you add that to both buckets, and then you present both numbers at the end.
Makes sense.
And so, especially for data sets with low contamination, this can actually have the runtime by doing it this way. I think it should be configurable. I think it should be off by default. But I definitely think it makes much more sense to keep it in the library than try to spin it out.
Makes sense.
Um, yeah. So I guess one of the questions that we need to answer is, are we going to focus on editing what we currently have, or are we going to like basically start a new library? I'm kind of inclined towards the latter. I think there's going to be a lot of stuff that we can copy and paste over, but I also think that there's enough stuff that we're going to seriously revamp or completely remove or completely rework that trying to perform a refactor on the library itself is probably not the best approach. One thing I will specifically call out is that I think that the UI for or the command line interface, the CLI, for this is pretty good. I think that you know the way that we call these models is very reasonable and something that we should basically preserve. The major thing I want to change is renaming GTP2 to Hugging Face. I also think that we should probably start by only supporting the Hugging Face library. The reason for this is that the overwhelming majority of stuff that we want to support is already in Hugging Face. The major non-example of this is the GTP3 API, but I think that I think that the design assumptions that will come with the Hugging Face library are, at the end of the day, going to be more representative of the way that people are using these because of how dominant Hugging Face is in the space. And I think that the server-based approach that you need for example, OpenAI's API is simply uncommon.
I mostly agree that we should sort of center things around what is supported by Hugging Face. Like, we've talked before about like implementing sampling ourselves, which I definitely think we should not do.
Mm-hmm.
But I don't know. I think it's important to sort of have the ability to, if it's sort of in a more limited capacity, still perform evaluations on the API models.
Oh, so I definitely don't think that we should like not perform evaluations on the API models. Let me rephrase that. I think that it is probably a good idea to what's the right way to rephrase this? I think it is likely the correct decision to, when we are building this from the ground up, start off by primarily focusing on supporting the Hugging Face library. I think that it can likely get a bit messy if we try to support all of the things that we have already. That we should aim for genericness, whatever that word is. But that like in our early proofs of concepts and stuff, we should probably mostly be running them through Hugging Face and not fretting super about the OpenAI API. Also, at the end of the day, the OpenAI API is an API, and it is much easier to kind of design a custom interface with. The Hugging Face models need to run on your computer, and there's a lot more restrictions that come along with that fact. Does that make sense to people? Okay, cool. So this is a really high priority item. This is, simply put, extremely important to do. We have a lot of technical debt that is caused by the fact that this has kind of grown to increasingly be a mess over time. And I have been talking with John, who is the former primary maintainer of this library, um, as well as with the Hugging Face and the Big Science evaluation teams. And there's a strong interest in promoting this, in organizing around this, and publishing a paper. I want to check when.
The Hugging Face team as well. I think that's really great because I know that they published the like evaluate framework, which I don't know if the code is public for that, but like their auto ML evaluation pipeline. But it would be great to not like compete with them on that. See if they can wait behind our solution.
Yeah. Um, yeah. What I'm trying to do right now actually is look up when the deadline for EMNLP demos are. Because that's like a very good venue to submit a paper about this too. Um, but okay, yeah, I think that we should really prioritize this and put a lot of, I guess, manpower and effort into designing this and orchestrating this well. Because I think that this is something that should be a high priority for us and is something that um, is important that we get right, and that the sooner that we're able to kind of fix and re-release this, the better off everyone is going to be. Um, so yeah, that's kind of where we're at and what we're trying to do with this. Questions, comments, concerns, objections?
I have some thoughts, but
Yeah, go ahead.
yeah, I mean, so I was looking at specifically how to like replace the requests API. I mean, just thinking about like not rebuilding everything from the ground up. And I think that there were like some benefits that I sort of noticed after looking at it, that like just like sort of preparing all of the data at once and then just like requesting responses from your model sort of has, and that's sort of like the like time estimation, progress bars that like make sense, like sort of like just like running your model in like one go, so you've got like high utilization. I think you could like make this better by sort of like processing your data asynchronously and just like then you start feeding data to your model as soon as you can start like preparing data points for it to see. Um,
So you mean desynchronizing the data preparation and the model running, because the model's running on GPU and the data prep is happening on CPU. Yes?
so that was a thought, basically both sort of why I understand why the requests API was done the way it was at the time, and also, yeah, I guess, but there is an easy way to make it better just by having that asynchronous processing. Like sort of, so like because like when I use the harness, like if I'm running on a ton of tasks, like I have to like download like every like MLU data set and like generate the split. But you could just like start feeding the data to the model like after you process the first data set, like process the rest in the background. That would definitely be a benefit. It's not really like useful to high level comment, but
No, I mean, I that does make sense.
so I'm just trying to think about like ease of use because for example like Mosaic put out that post about their sort of evaluation framework, which I don't know that like it's a framework that people frequently use if they're not already using Mosaic's library, but they're sort of like emphasizing like ease of use and like quick turnaround on evaluations, and that's definitely something that we could like strive to do better on. Like implementation should be like hackable,
Mm-hmm.
but then we should also really focus on like just having it like not take longer than it should to run on these. Um,
Yeah, I think that absolutely makes sense. It's actually kind of interesting because I wonder how often, at least for like very large models, people are waiting longer to download data than they are to load the model. Like the data processing is probably faster than the putting a 13 billion parameter model on GPU is, right?
yes, if you don't have the data sets, the data sets are pre-downloaded, I think so.
Hmm.
Because yeah, definitely when you're like using Hugging Face Accelerate with like CPU offload, it takes a while to load the model in. Um, I've experienced that with like the prompt source harness.
Yeah.
It takes a very long time to start up in some cases if you're like running a very, very large model on not that much hardware.
It's definitely something to think about. I'm not strongly attached to like throwing everything out and starting from the ground up. I see John has joined us. Maybe he has. Right now, we're talking about whether it makes sense to throw everything out and start from the ground up or not. Basically, kind of my thinking is that we have a lot of mismatched and not necessarily particularly well designed stuff going on, and that whether even though we are likely going to be copying and pasting a large amount of code, sometimes even entire files, it might make sense to kind of set the library aside and try to rebuild it from scratch instead of trying to like do a live refactor of the library.
Yeah, I mean, that's what I would do honestly. Start from scratch and just pull most of the reusable stuff.
So let me start something. Um, does anyone know off the top of their head what licensing the library has?
Let me check.
It's very possible the answer is there isn't one. I know it's MIT.
Yeah.
Yeah, so yeah, I would have assumed it was MIT.
Eric, there's something that's like very wrong with your mic setup. It's
Very warbly.
Figured it out. Yeah, it's Leo, so I would have assumed it was MIT.
cool. So we now have a library called or a repo called LM-eval2 um, under Luther AI, which we can focus on doing this work in. And I do think a lot of it, like I said, is going to be copy and pasted. A lot of it is going to be very similar to the original library, but I think that kind of stepping away from the original library is probably a good idea. We can do an in place replacement, honestly, once we have it built in working. so that the experience, because we're not going to be changing the API really, except for like the CLI, except for getting rid of the very, very silly convention around Hugging Face models. So I think that it's really not a big deal to kind of just develop it separately and then copy and paste it over what is currently there. And we can add some warning flags and stuff. So I think a good starting point is to aim to put kind of the general architecture that we're going to be looking at. The abstract classes, kind of the organization, and not fret as much about the details, but make sure that we kind of have a vision in place for how this is going to, how the data is going to flow and how this is going to work at a high level. I just realized I forgot I'm not sharing my screen again. My apologies. But I'm looking at the new repo that I just made. How this works? I always forgot this syntax for some reason. Yes, that is correct. And what is in here actually? Nothing. It is empty. Because Python is weird. Cool. So over the next, I don't know, couple weeks. So Haley and I have a paper that we kind of intended to be done with a month and a half ago and still aren't done with, that we really, really need to finish. But other than that, I think this is kind of our highest priority thing. I mean, I also have like a lot of administrative stuff to do as well. But in terms of stuff that, like technical work, this is very high on my to-do list. What's a good example task? Does anyone have a recommendation for like just a placeholder example task to add?
Good example.
Mm-hmm.
Lambada.
That would be my recommendation.
Just kind of filling out some of the.
I don't think I'm not sure if you want to copy over all the dataset stuff. Like that stuff is only specific to like backwards compatibility with some of the way we handled the datasets before they were put on Hugging Face. So that's just like implementing them in Hugging Face and Hugging Face datasets.
Oh, right. Because because I'm confusing datasets and tasks.
Yes.
Nice catch, John. No, I was like looking at it and going like, where is everything? Why is this not looking the way I expected to? Yes. So tasks, data.py. So for people who haven't really used this before, if you go to the tasks directory, we have one file per task, and we kind of have this template that we're using. You have some natural language description of the thing. You have citation information, and then you just have like particular properties that you need to define. Here, there's actually like 2 different versions of this task, because OpenAI changed it when they did the GP3 paper. Because changing it makes it work better, and therefore they should change it. In terms of versioning, so one thing that we have is like versioning of all the tasks. We should probably update the versioning of everything to be uniform. Actually, so I kind of recommend changing versioning from a number to a string, and we can make them all 2 point whatever. This is version 2 of the library.
Yeah, it's good. Yeah.
So we now have a task. And really the hard part, or the most important part, is kind of the interface between. I always found this weird. Is this really necessary?
where we assign names to tasks. So
Why isn't that an attribute of the task? Why don't we have a dot name?
Yeah, you can just use the class. I don't know. It should be an attribute though.
So like we have an abstract. So this is actually not going to run anyone because we don't have a task currently. But let me grab the base. But yeah, no, like we can make lm eval base.
The dictionary is used to look up the task for taking the task name from the command line and then mapping that to a class.
Going the other direction, going from the command line to the task itself.
yeah, like these names are what the user uses.
Okay, yeah, I guess it's doing it in that. I was thinking about the other direction. But yeah, no, going in that direction, that does make a lot of sense.
It probably can be automated though. It probably does not need to be a hard coded.
Yeah.
Yeah, you can
No, we
get
can if we give each model a name attribute, we should be able to definitely automate the creation of that directory. Cool. So I'm kind of just setting some of the basic stuff up, but is there questions, comments, like people have opinions they want to voice? I know I've mostly been doing the talking, but like no, this one is the actual task one. So for those of you who are new here, and kind of checking this out for the first time, are you interested in contributing? Does this sound like something you want to spend some time working on?
Still, it's probably a good idea to provide a little bit of context about I guess maybe just the eval harness in general for the new people.
Oh yeah, I did that at the beginning, but I can do that again.
All of this is recorded, by the way.
Yeah.
Curtis.
Okay, perfect.
But yeah, this is a library that we built like a year and a half ago, 2 years ago. By we, I mean like 80% Leo Gao, 10% me, and then over time like 10% John. Probably, honestly. But the purpose of the library is to provide a uniform way to carry out evaluations across a wide variety of models and a wide variety of data sets so you can actually have comparable stuff. Because what people currently are doing in most organizations is copying numbers from other papers, and models are extremely sensitive to very minor changes in how evaluations are orchestrated and how they're evaluated. And as a result, the numbers that come out of this are of copying stuff from other people's papers is very often meaningless. And unfortunately, we're kind of in a situation where the people who train models and the people who evaluate models tend to be, the people who train models and the people who develop new evaluation benchmarks tend to be different people. And so you have like individual repositories where people are releasing benchmarks, and then you have individual repositories that people are building around models. And someone has to actually take one and port it over to the other. And there's very little cross-compatibility, and this is a very error-prone process. We have many times had the experience of finding out that we were making to a human, totally reasonable design decision that just happened to not be the one that they made in the original paper, and it can make a very big difference in the benchmark performance. So we actually have dataset name and dataset path.
So
But
does the
those are
name
Hugging Face specific,
uh,
right? Or those
dataset
are
name is dataset name is the subset.
like split one
Like
or
like
hard for
sub
like arc.
the sub dataset. Um like is like one data set on the Hugging Face hub, but then the specific task is a subset of that data set, which has its own splits.
Can you try saying that in a different way?
Yeah, it's like data sets have like three levels. There's like the overall data set, and then there's sort of like subsets of like divisions of that data set. And then those subdivisions have like a train, a validation, and a test split.
So I think arc is probably a good thing to. Whoops. Again, I clicked on datasets. The fact that I keep clicking on datasets instead of tasks is maybe a sign that having the datasets the way that they are is not a great idea. I think arc is a good illustrative example of what you're getting at. Or ANLI is actually even better because they're different rounds. So ANLI has 3 different versions called round 1, round 2, round 3. So this is the base class, and this is a good way to see kind of how this is designed. So this is a base class, and then we have a class that inherits from it for each of the different splits. Now I notice this is actually called split. It's not called dataset name. So dataset name looks like it's never actually defined for this.
That looks. I think that is non-standard.
Me, ANLI should be a central example of this. The thing. Actually, it looks like this is pretty non-standard. So let's see. Here we have arc. So we have arc easy. So dataset path is arc AI2 arc. AI, that's probably the Hugging Face name for the thing. Then we have arc easy. And we have arc challenge as well, which inherits arc easy, which is also not something that should be standard.
This is how. Sorry, this is what I was trying to explain with dataset name. So in this case, both arc challenge and arc easy live under AI2 arc dataset on the hub.
Yeah. Yes. Thank you for calling that specifically. I followed that, but I did. It's possible that other people did not. What I was calling out was that this is very poor design, where we actually have arc challenge, inherits from arc easy, and then overwrites the name so it's different. That is.
Well, but is the rest of everything else, it inherits because it's all identical?
Yes.
Other than the name. Okay.
But that's not a good design practice. That means
Yes.
that if they introduce a new arc, arc very challenging, that has a slightly different methodology, for example, we're gonna have to like rebuild this whole thing. Also, I think that in general, this is going to be very misleading to a user. Like this looks confusing. Like you can work out what's going on here, but the way that we handle situations like this should be uniform, and I think it should be to have a base class that implements the logic, and then have arc easy, have arc hard, or arc challenge.
Have base class. Yeah.
Yeah, and like that's what we do in ANLI.
I didn't think of that.
For example, which is non-standard in a different way.
An arc base class, and then the name and path are just inherited from that into easy and challenge.
Yeah, exactly. That's what we do in ANLI. So we have this ANLI base. It tells you, this is the path is ANLI, but the name is currently none because which name you need depends on which subset you're using. And then down here, but the weird thing here is that we choose to not use dataset name at all. And instead we've introduced this new thing called split, which seems like it's at least, like maybe there's a detail in the way this is implemented on the Hugging Face hub or something where this makes sense, but this is surprising to me. I was expecting split to be dataset name, And then down here, we, when we instantiate each particular version, we tell it what dataset name to use. I hope there's an example of this. What's a...
I'm gonna need the dip soon, so.
Yeah.
Sorry.
Math QA might have stuff. No.
Hendrix test may.
Sorry.
Hendrix test might. Be
Hendrix test is task is super custom. It's like no. No, and you don't want to know why is kind of where that's coming from.
The base task class is super custom. Everything is subclassed off that and is not. I'm not sure I follow.
So so here's actually a good example, I think. I hope. So this is Blimp. Blimp is a challenge set for analyzing grammatical phenomena, the ability to determine specific kinds of grammatical things in English. I have some issues with the evaluation metric itself, but let's set that aside. I think the implementation here is probably pretty good. On first glance, it looks pretty good. So Blimp has 57, I want to say off the top of my head, different tasks it implements. And so these, each one targets a specific grammatical property. So we have this, but they're kind of all the same. They just have different strings to test different types of grammatical structures. So we have this kind of general implementation. We define the dataset path as Blimp, and then we inherit from that a task-specific name. So Blimp determine noun agreement with adjective. So this task here, make sure that the number of a noun, and no, it doesn't actually do gender. Even though it checks that the number of a noun agrees with the number of the thing it's modifying. And specifically tests a model's ability to understand the difference between that. And so we have each of these different kind of types of the Blimp task, and they each define a different name, which basically tells the library where to look for the specific data it's loading, but all of the unified, consistent data processing and such is done in this base class called Blimp task. Might be worth...
So you have,
yeah,
40 different subclasses, and the only thing they override is the dataset path.
For this particular example, yes. There are other tasks.
I'm gonna have to dip. Sorry.
Bye.
So I'll post the recording later.
Oh, Eric, I have a recording running. Don't worry about it. That's video
okay,
and audio and everything.
Okay, good. Thank you. Bye.
Yeah, so let me open up the Hugging Face hub. So most of our data sets are being loaded from Hugging Face. As a side note, most of our models are also being loaded from Hugging Face. This is a bad way to go about doing this. I want to open a specific data set. Let's open ALNI. Let's do Blimp, because we were looking at that. So when we, it's 67, not 57. So when you go and open Blimp, they don't have a dataset explorer for this, do they? Dataset preview is not available. Okay.
Go to dataset viewer.
Sorry?
Back one. Back a page, and then top right, go to dataset viewer. Go to dataset viewer.
Yeah,
Right
so
the
that wasn't
dataset
supported
preview.
for Blimp, was kind of the issue. There was an error message in the thing. So it's not actually showing the data. Maybe they have a backend issue. But you can see that they have these splits, different splits. Oh, that's probably why. It's probably because in the Hugging Face library, they call them splits for some reason, and that's like a hard-coded field. We really need to do a survey of all of the weird idiosyncrasies in the Hugging Face library. Alas. But yeah, so the core idea is that the dataset name So the dataset path is like, in this case, ANLI. And then the dataset name tells you kind of where in here to go. Whether or not these are the right field names is kind of its own conversation that we can definitely have. But that's kind of the intention. And for most models, you're going to have, or sorry, for most tasks, you're going to have the same core logic across different stuff because they're like different versions or different splits or different data collections. But one reason to kind of structure it like this is that it does provide easy support for if there is something different. So there is a task that I think we don't support in the eval harness, but which I would like to support that does, where the different splits actually have different metrics that they use. Like one is an accuracy thing and one is like an F1 score. And kind of organizing stuff like this makes doing that a lot easier. You can override the process results, for example. You can override kind of whatever is task specific and generalize whatever is not. So that's kind of why I think that this general structure is a good idea, even if it seems that we don't actually follow it a lot of the time. But hey, that's why we are making a new version of the library. So I see that this has gotten a bunch crowded, or not crowded, but like a lot more people have shown up since we started talking. So this is all being recorded. I'm gonna post this probably on our YouTube channel and drop a link to it in the Discord. I go over some of at the beginning I talked about some of kind of the motivations and goals of what we're doing, but high level, we have a really cool library for doing language model evaluation, but it's kind of haphazard. It suffered a lot of scope creep over time, which is fine because I think the new scope is good, but it certainly wasn't designed for from the beginning. And there are some historical idiosyncrasies which are, in retrospect, kind of embarrassing. The most egregious of this being the fact that if you want to run an arbitrary Hugging Face model, you call G2B2 as your model, which is definitely not ideal. And so our goal is to kind of rebuild and refactor this. I think that stuff has gotten messy enough that it's probably worth just doing it from scratch. We're going to copy a lot of code over. We're definitely going to keep a lot of stuff as it currently exists. But I think that starting fresh and copying things in is likely to be more productive than doing things live. So yeah, that's where we're at. This has now, I guess, been an hour. Welcome to everyone who is new here. This is definitely something that I think is going to be benefit substantially from having some extra hands-on. If you have experience with hacking language models and especially with like, implementing custom stuff in Hugging Face's various libraries, that's a very useful skill set that we can definitely put to work on this. The kind of hardest part in terms of knowledge or skills is kind of, we want to do auto parallelization. We want to kind of handle some of the large scale stuff automatically and behind the scenes. Probably using FSDP. Haley, do you have a strong preference about that?
I was thinking that we should support accelerate the way that the prompt source harness does for like large models on small hardware, even though it's slow. And then I think FSDP probably.
Yeah. Because FSDP doesn't support CPU offload, right?
It does. That's a good point.
Like the main use case I see for people using Accelerate is wanting CPU offload. Because at the end of the day, like, if you are trying to run this on multiple nodes, you're doing something wrong.
Really? Yeah. I was thinking of like disk offload that Accelerate has for like, because like I've run like OBT 66 billion on like a pretty small GPU in the prompt source harness. I think that's useful enough to have like an option for it. And I think other than that, FSDP.
I think that we're saying the same thing. I'm calling that CPU offload.
Yeah.
Apparently, Accelerate calls that disk offload. My terminology is probably just copied from DeepSpeed, honestly, and therefore is not necessarily better, but whatever. Yeah, so disk offload, CPU offload, whatever you want to call it, is definitely something you want to support so that people with low resources can very slowly run very large models. Cool. So, thank you so much for coming, I guess. Any closing thoughts, closing questions? Anyone excited to build a library to do language model evaluation?
Yeah.
Cool. So actually, one quick thing to sing on. Haley, what is your? So obviously, we need to finish the Pythia paper. The final models are currently running, right?
I am still waiting on the burst capacity for people to move off the other cluster.
Okay. For how many steps do we need to run or let me rephrase that. How many tokens do we need to run the 12 billion parameter model for still?
10K steps, so
30 billion?
yeah, I guess a bit more than 30 billion or something.
Yeah, because it's yeah. So 30 billion on a 12 billion parameter model is 3600 is 360 is wait, so it's 90% of the way done? Or 95% of the way done?
I think it's like 87% done or something. 18K is more than like 10% of 143K, but it would take 2 days on 32 nodes to complete.
Yeah. Okay. So you and I should probably have a chat about. So almost. All right. So let's. Okay. Well, let's have a conversation about kind of bandwidth and priorities. I guess offline because people don't need to listen to me stutter and try to do math live while we figure out what exactly we're blocking on for the Pythia paper and how that's going to sort out. But kind of my thinking is that this is probably the highest priority non-Pythia thing. I would really like you to focus on working on it. If that makes sense.
Yeah.
John, I know I promised that I would never ask you to work on this ever again in your life. So I'm not going to ask you to work on this ever again. But if you are interested in working on this of your own volition, zero obligation. I really did mean it when I said I was never going to ask you to work on this again. That would be nice. But definitely don't feel guilty or like there's an obligation to do that.
No, I'll definitely throw some commits in there to get through line. So yeah, I'll be around.
Cool.
By the way, will this be a weekly meeting?
Um,
You guys...
maybe. Basically, Haley and I were talking about how we should probably sync up and make sure we're on the same page because we've been kind of drafting things in a group chat, and then I figured that this was something we might be able to benefit from having additional hands-on, so I threw it up on the Discord. I think it is probably a good idea to have a weekly meeting, but I'm not committed to like this time quite yet.
Okay.
All right. Thank you so much for coming, everyone, and have a good day.